This is your quiz. Yeah, the answer to number 1 is 25. The rule, start with 200, divide by 2 repeatedly. Number 2, 3y plus 5 for y equals 8. What am I going to do here? What am I going to do? Emily, what am I going to do? It's called replace the y with the 8. How do I replace it, though? It's very important. How do I replace it? In parentheses. I need to rewrite that y. Instead of it being a y, I'm going to rewrite it with the 8, but I need to put it in parentheses. It doesn't seem important now. It is important. 3 times 8 is? What's 3 times 8? 24. What's 24 plus 5? 29. That's my answer. 29. Question? That's fine. As long as they get the answer right, they're lucky. Yeah. It's fine. On a quiz, all I'm looking for is the answer. Number 3. They've given you the rule. You have an x. What's happening in the next column? Here's the x. What's happening in this column here? Being multiplied by 3, right? Whatever x is, you're being multiplying it by 3. Notice that 0 and 0, that works, right? 100 and 300, that works. So 5, what does it become right here? 15. 5 times 3 is 15. That's the answer. Over here, you'll notice in this one, this is the x, and this one is 8 minus x. I hope you noticed this is, this one was a 2. 8 minus 2 is 6. That's why it works, right? 8. If it's 8 minus 8 is 0, that's why it works. What if x was 5? What belongs here? What if x was 5? What belongs there? 3. 3 is the answer to number 4. 3 is the answer. All right, the next lesson is lesson 3.3. Writing algebraic expressions. Listen, this is important, so I really hope you're paying attention. There's way more than one way in a word problem to write addition. Right? In a word problem, it's not always going to say, I have 7 apples and I add 6 more apples. It's not going to say that. They may say, the sum of 7 apples and 6 apples. What is the sum? What does that word sum mean? You guys should know this from your past. What does the word sum mean? S-U-M? You're not adding, right? It's the answer to an addition problem. What is the word for the answer to a subtraction problem? What is the word? Is the difference, right? If I say, what's the difference between 10 and 8? You go with the difference. Oh, difference means the answer to a subtraction problem. Oh, 10 and 8. The answer would be 2. What is the word for the answer to a multiplication problem? Product. Product. If I say the product of 3 and x, that means 3 times x, right? What's the word that you use? Don't say it out loud. What's the word that you use for the answer to a division problem? Quotient. Quotient. You guys are in advanced math class now. You need to learn those words. Those words are common. You'll see them a lot. Sum is addition, difference is subtraction, product is multiplication, and quotient is division. There's other ways of writing these things too. If I want to say another way of saying multiplication, what else could I say? There's the product of this, blah, blah, okay. What else? What else could I say for multiplication? What else could I say for multiplication? Times, right? If I weigh 2 times as much as you do, which is probably not true, it's probably more like 3 times, but if I weigh 2 times as much as you, what am I talking about? I'm talking about multiplication, right? What's another word for addition? What's another way in a word problem, a story problem, for me to be talking about addition? There's the sum of total. Absolutely, that's a good word. What else? What else? In all. Absolutely. What about they even might use the word plus. right? Plus. More than, right? More than. You can look on page 118. They give you some word phrases that are common in algebra expressions. Look at page 118. For addition, notice this, the algebraic expression is m plus 45. There's three different ways they say you can write that. There's m plus 45. There's the sum of a number m and 45, the sum of m and 45. And then there's 45 more than m. Three separate ways of writing m plus 45. Are you noticing that? Do you see that? All of those mean m plus 45. Same thing with subtraction. A number p minus 6, that's obvious. The difference of a number p and 6, and then 6 subtracted from p, right? Anyway, let me go over this here with you. Let's do a few practice ones. I want to show you. Write that for me. Write that algebraic expression for me. Write it algebraically, properly. The algebraic expression. How many of you have this? How many of you have that? Yeah, you're wrong. That's wrong. It's very important, and I'll show you why here in a second. What was there first? When I say 8 more than x, 8 more than x, what was there first? What was there first? The x was. 8 more than x means that the x was there and they've added 8 more to it. Does that make sense? It should be x plus 8. You could say, Mr. Duncan, what's the difference? I agree. And when it comes to addition, there really is no difference. Answer this one for me. Does the order of a subtraction problem matter? What is 8 minus 5? 3. What is 5 minus 8? Negative 3. Oh. So see, when it comes to subtraction, the order does in fact matter. So then, because of that, I require that you even do the more thans the right direction. 7 less than y. What's less than what? How much is there? Who is there first? 7 less than y. How much was there first? Y. Y was. And it's 7 less than that. Does that make sense? That's why it's important that when you see more than or less than, you know what order they go in. You have to decide what was there first. Does that make sense? That's the confusing part, is the more than and the less than, because they're reversed. You have to decide what was there first and what is actually being added to it or taken away from it. Okay? Let's try this. Let's try this here. Do 7 through 15 odd right now. 7 through 15 odd on page 121 right now as practice. 7 through 15 odd on page 121. That's 7, 9, 11, and 13, and 15. Do those numbers right now.
In the answer problem?
No, just on scratch paper. All right, let's see how you did. Number 7 says 34 less than k. 34 less than k. Because it says less than, you have to decide which one was there first. K was k minus 34. That should just make sense to you. 34 less than k is k minus 34. If you think about it, if I have 5 less than 8, if I have 5 less than 8, how much do I have? If I have 5 less than 8, how much do I have? Tell me. I have 3. That's 8 minus 5. 5 less than 8 is 8 minus 5. Right? Okay, number 9. D, more than 50. Ooh, it's a more than. Which one was there first? 50 was there first. Plus D. Number 11. 7 decreased by B. Decreased by. Now this one doesn't say less than, right? This says decreased by. This one is, the one that was there first was 7. And it was decreased by B. So this actually is 7 minus B. Does that make sense? When you say 7 decreased by B, 7 was there first. Number 13. This one was really straightforward. 13 minus D. How do I write down 13 minus D? 13 minus D, right? It's very straightforward. 15. N less than, there it is again, N less than 19. The 19 was there first, and the N is less than that. How many of you got all 5 of those? Correct? Yeah, that's not good. That's not good. Gonna have to pick it up because you're doing 4 problems right there. Okay, the next section here is this. You're gonna tell me, I'm gonna give you a table, okay? I want to know what the rule is. What's happening here? Here's N. It went from 10 to 7, 12 to 9, 15 to 12. What's the rule? What goes in there? What goes in there? What goes in there, Michael? N minus 3, exactly. N minus 3. Do you see it? Let's see if you can do number 19. Do number 19 for me right now. How many of you have the answer? Joy, what do you have? N plus 2, right? 3 turns to 5. That's adding 2. Who adding 2? They're all adding 2. N plus 2 is the answer, right? Okay, last one. Do number 21. Do number 21 right now. You're in the advanced math class, and we're talking about algebraic expressions. So I'm going to want you to write this algebraically. So we'll see how many of you did that right. We'll see. What is going on here? What's happening with each one of these? What's happening with each one? Caleb?
It's multiplying by 11.
Multiply by 11. So then, what belongs here? What belongs there? Donovan? He said N11. How many of you have that, N11? That's not true. That's wrong. It's correct, but it's not algebraically the way that you write it. Does anybody have a better answer? Sladen. It's 11N. Here's the thing. Let me tell you the rule about algebra. Whenever you have a number and a variable multiplied, it always goes number variable. That's just the rule. You don't say y5, you say 5y. It's just algebra. It's one of the rules of algebra. Whenever you have a number and a variable, you say the number first, then the variable, and you smush them. So this is 11n. Make sense? Make sense? Okay. I think you guys are going to do just fine on this homework. Let me see. Yeah. Let me give you your homework then. Right algebra, okay, so page 121 to 122, 7 through 21 even, and yes, Mr. Gang.
Since for division and multiplication, is there a way for the expression for it to be switched?
Good question. What do you mean?
Is there a way for division and multiplication for when you do like less letters? Is there a way for those two to get switched?
No, not really. If they say the quotient of blank and blank, the first number that's said is the numerator, the bottom one, the second one is the denominator. And multiplication, it doesn't matter because you're always allowed to switch them. But you always, when you write it number variable, right? Okay. Do you know how you algebraically write division, people? Do you know how to algebraically write division? If I have this, x divided by 5. Do you know how to write that algebraically? Do you know? It's this. It's x over 5. That's how you write it algebraically. That's still divide by, but that's just the way you do it. Anyway, you don't need to worry about that today. Actually, you do, huh? There is one. There's one that you need to do that. I don't care. I mean, even if you did this, I'm not too worried about it. But if you want to get technical, it's that. That's how you write it. All right. Anyway, there you go.